We've all seen how AI, powered by, well, just massive amounts of human data, think large language models, it's really exploded recently.
Yeah, it's been everywhere.
But what if the real revolution, the next big leap, isn't just about AI copying us better? What if it comes from AI learning through its own experiences, potentially unlocking things, breakthroughs we can't even imagine right now?
That's a pretty exciting thought.
It is. And that's what we're diving into today, this potentially game-changing idea called the era of experience in AI.
And it's spearheaded by a couple of real heavyweights in the field.
Absolutely. We're talking about David Silver, who famously led the AlphaGo team at Google DeepMind.
The one that beat the world Go champion. Incredible stuff.
Exactly. And Richard S. Sutton, a Turing Award winner, basically one of the founding fathers of modern reinforcement learning, wrote the textbook, literally.
Yeah, foundational figures. So their argument, the core of it, is that this current phase, the era of human data, well, it's kind of approaching its limits.
Limits? How so?
Well, their vision is that the next stage of AI progress, the kind that might actually lead to superhuman intelligence in, lots of different areas, that's going to be driven by AI actively interacting with the world, learning from it directly.
Okay, so less learning from books and websites, more learning by doing.
Precisely. And they argue this isn't just like a far-off sci-fi idea.
Hmm.
We're maybe already seeing the beginnings of it.
Oh, like where?
They mentioned things like AlphaProof, for example. It's a system that's doing surprisingly well in math competitions, using methods it discovered itself, methods that are, well, different from how humans typically solve those problems.
Interesting. So today we're going to unpack this era of experience, right? What does it actually involve? Why is it such a big shift? And maybe what could it mean for, for you listening?
Exactly. Let's get into it.
Okay, so the central idea is that training AI just on human data, that can only take us so far. Why is that the limitation? Why isn't human data enough?
Well, think about the absolute cutting edge of knowledge, like advanced mathematics or fundamental scientific discovery, or even really complex coding problems.
Okay.
The truly groundbreaking stuff, the next big theorem, the next revolutionary technology, hasn't been written down yet. It's beyond what any human currently knows or understands.
Right, it doesn't exist in our collected knowledge base.
Exactly. So if an AI is only learning from the data we humans have created, our texts, our code, our scientific papers, it's fundamentally limited by our current understanding.
It can get really good at what we do know.
Incredibly good. It can replicate, synthesize, even improve on existing human knowledge and skills.
Yeah.
But making those leaps into the truly unknown, that requires something more than just analyzing our past achievements.
Okay, that makes sense. You can't learn something that hasn't even been conceived of yet. So how does this era of experience propose to get around that? What does it actually look like?
They outline a few key characteristics, kind of shifts from how things are often done now.
Uh-huh.
The first one is moving towards continuous streams of experience.
Streams. What do you mean by streams?
Think about how you often interact with AI now. You ask a question, maybe get an answer, and the interaction is pretty short, self-contained.
Yeah, like a quick chatbot conversation.
Right. The era of experience envisions AI agents learning through ongoing, long-term interactions, sustained engagement.
So, give me an example.
Okay, imagine maybe a personal health assistant. Instead of just answering one-off diet questions, it monitors your health data, activity, sleep, maybe other metrics over months. It sees trends, learns what works for you, and adapts its advice over time to help you reach, say, a long-term fitness goal.
Ah, okay. So it's learning with you over time.
Exactly. Or think about a science AI. It might run simulations, propose experiments, analyze results over weeks or even months, all focused on a specific long-term research question. It's about persistence and adaptation.
Got it. So less like a quick Q&A, more like a long-term collaborator or observer. What's another key part?
The second big shift is about actions and observations, how the AI interacts. A lot of current AI, especially the big language models, interacts primarily through text, right? Human language.
Yeah.
The era of experience emphasizes AI acting more autonomously within an environment using what they call grounded interfaces.
Grounded interfaces, like...
Think about how, say, an animal learns or how we learn. By doing things in the world and seeing what happens,
Us.
observing consequences.
Okay.
So in the digital world, this could mean AI agents that can actually use software interfaces, click buttons, call APIs, navigate websites, much like a human does.
Yeah.
We're seeing early steps towards this already from companies like Anthropic and OpenAI.
Right, agents that can operate a computer.
Yeah, and potentially this could even extend to the physical world AI controlling robots,
Yeah.
using sensors to perceive the environment directly.
Wow, okay. And the benefit there is?
The benefit is that the AI isn't just passively consuming data, it's actively exploring. It can try things out, experiment, and potentially discover strategies or solutions that humans might never have thought of simply because we're constrained by our own habits or assumptions.
So active exploration, learning by doing. That makes sense. How does it change how the AI figures out if it's doing a good job or not? The whole learning signal part.
Yeah, that leads perfectly into the third point, rewards.
Okay.
Right now, a lot of AI tuning, especially with language models, relies heavily on human feedback. Humans rating responses, telling the AI good job or bad job.
RLHF, reinforcement learning from human feedback.
Exactly. The era of experience puts more emphasis on what they call grounded rewards. Rewards that come directly from the environment as a consequence of the AI's actions.
Okay, so less human opinion, more objective results.
Sort of. Instead of asking a human, was that a helpful advice from the health AI, the reward might be derived from actual improvements in your measured heart rate variability or sleep quality over time.
I see.
Or for an AI trying to discover a new catalyst for a chemical reaction, the reward isn't a chemist saying, that looks promising.
Right.
It's the measured efficiency or yield from the simulated or real experiment the AI proposed.
So the environment itself provides the success signal.
Exactly. The argument is that these grounded environment-based rewards are necessary to push beyond human capabilities and biases. Although human guidance can still play a role, maybe in helping to define what constitutes a good outcome or shaping those reward functions.
So humans aren't totally out of the loop, but the primary feedback is from the task itself.
Right, and this connects to a really interesting idea called the reward is enough hypothesis. It basically suggests that if you have a sufficiently well-defined goal or reward within a rich enough environment, optimizing for that reward might be all you need for complex, intelligent behavior to emerge.
That's a big claim.
It is, but it's influential.
Okay, so we have continuous streams of interaction, actions, and observations in an environment, and rewards coming from that environment. How does all this experiential learning affect how the AI actually thinks? It's reasoning and planning.
Yeah, this is where things could get really different. Planning and reasoning. Today's AI, even when it seems to reason, often does so in ways that kind of mimic or are trained on human thought processes found in text.
Right, it learned from how we explain our reasoning.
But an AI learning directly from the consequences of its actions in an environment, it might develop ways of planning and reasoning that are, well, more efficient, more direct, perhaps completely non-human-like.
Like the AlphaProof example you mentioned earlier, finding different kinds of mathematical proofs.
Exactly. It found proofs that worked, that were valid, but structured differently than typical human proofs. It wasn't constrained by mimicking human mathematical traditions.
So it could be more effective, even if it's harder for us to follow its logic initially.
Potentially, yes. And crucially, grounding reasoning in real-world interaction and observation helps avoid just inheriting flawed human assumptions or biases that might be embedded in our data.
Makes sense. It can test its ideas against reality.
Right. It facilitates a kind of scientific method for the AI, form a hypothesis, a plan, test it through action, observe the outcome, update understanding. This often involves building what are called world models.
World model.
Yeah, internal representations, sort of simulations of how the environment works. These models allow the AI to predict the likely consequences of different actions before taking them, which enables much more sophisticated planning and look ahead.
Okay, that paints a pretty clear picture. AI learning by doing, getting feedback from the world, potentially thinking differently. Why is this shift happening now? What makes the era of experience feasible today?
A big part of it is the foundation laid by reinforcement learning, especially in simulated worlds. We saw RL agents achieve superhuman performance in really complex games. Go with AlphaZero, chess, even Atari games back in the day.
Right, learning just by playing against themselves.
Exactly. They discovered strategies that humans hadn't found in centuries of play. Now, for a while, the massive success of LLMs trained on human data kind of shifted the focus.
The era of human data took center stage.
It did. But that underlying power of RL, the ability to learn and discover knowledge autonomously through interaction, that's fundamental to this next step.
So the RL tech matured.
Yeah, the algorithms got much better, capable of handling more complex, open-ended problems. And combine that with the progress we're seeing in creating more capable, autonomous agents, AIs that can actually use tools, interact with digital environments.
The pieces are falling into place.
It seems that way. The success in simulation proved the concept, The data era gave us powerful base models, and now combining these with agent capabilities and advanced RL seems like the path towards learning from experience in more complex, real-world or realistic digital settings.
Okay, so let's bring this back to the listener. For, busy professionals, knowledge workers, what are the potential implications? What could this actually mean in our daily lives or work?
Well, looking at the potential upsides first,
Yeah.
they could be pretty significant. Imagine having AI assistants that aren't just good at answering one-off questions, but genuinely understand your long-term goals.
Like the health example.
Yeah, or in your career development or education. An AI that learns with you over months or years, adapts to your progress, and provides truly personalized, proactive support based on that shared experience.
That sounds incredibly useful.
And then think about science and engineering. If AI can autonomously design experiments, run simulations, analyze data, and learn from the results, the potential to accelerate discovery in areas like medicine, material science, climate modeling,
Yeah.
it's huge.
Potentially speeding up breakthroughs dramatically.
Exactly. Now, of course, there are also challenges and risks to consider.
Right. What are some of those?
Well, the obvious one is job displacement. As AI becomes capable of more complex autonomous tasks, the impact on certain jobs could be significant. We need to think about that.
Definitely. And safety, more autonomous agents. Sounds like there could be risks there too.
Absolutely. Ensuring these more autonomous, experientially learning agents are aligned with human values and operate safely is a critical challenge. How do you ensure an AI pursuing a long-term goal via grounded rewards doesn't lead to unintended negative consequences?
That's a big one.
It is,
Yeah.
though interestingly, the author suggests there might be some potential safety benefits to this experiential approach too.
Oh, how so?
Well, agents learning continuously from experience might be better at adapting to changing situations or environments than models trained on static datasets. And if a goal is slightly misaligned, maybe the ongoing feedback loop offers more opportunities for correction over time compared to a system deployed with fixed objectives.
Okay. And maybe the pace of real-world interaction acts as a natural break compared to purely digital simulation.
There's another point they make: interaction with the real world, or even complex digital systems, often has inherent delays and costs, which might naturally slow down learning and deployment compared to purely simulated environments, giving us more time to observe and react.
Interesting perspective. Okay, so to kind of wrap this up, the main takeaway here is we might be heading into a new phase for AI, right?
Yeah, a significant shift, moving beyond just learning from the vast archives of human knowledge
The era of human data.
towards AI learning primarily through its own direct interactions and experiences with the world, the era of experience.
Driven by the limits of data-only approaches and enabled by advances in autonomous agents and reinforcement learning.
Exactly. Characterized by things like continuous learning streams, grounded actions and observations, environment-based rewards, and potentially novel, non-human ways of reasoning.
It's a pretty profound shift to think about,
It really is.
which maybe leaves us with a final thought for everyone listening. As AI potentially starts learning in ways that are fundamentally different from us, learning directly from the world itself, what entirely new frontiers of knowledge, what kinds of discoveries and solutions might be unlocked that we right now can't even begin to imagine?
That's the big question, isn't it?
It certainly is. That's our deep dive for this time. Thanks for joining us.